Hey, and in this video, we are going to be talking about variables and data types. So let's create our file, and we're going to call it one underscore variables dot py. And the types of data types in Python include integers, floats, boolean, and strings. So what are variables and what are data types? Variables are a way in Python to store some kind of value into a name that you create. So for example, if we had a variable named integer1 and we set it equal to 65, this would be an integer variable. Integers are negative numbers without decimals. So let's say negative 100 or 1000. Or they could be positive numbers without decimals, so such as 70. Floats, so we'll say float1 is equal to 19.99. Floats are negative or positive numbers with decimals. Boolean are true or false values. True or false in Python starts with a capital. And string are a piece of text. So we could say this is string 1. And these are technically arrays of characters. And we'll get into that a little bit more later on about what a string of characters means, or an array of characters. But now that we've defined these variables and we know the kinds of their data types, what we can do is, if let's say we didn't know the data type, we can print to our console the type function, and inside of the type function we can pass in our variable name, so integer1. Now, another thing to point out is we've defined this variable, integer1, and so that's the name of our variable in our Python code, and we've assigned it this value of 65, which is an integer, okay? So now when we print the type of integer1, what will happen is it will print out to our console the integer class. So when we say Python one underscore variables dot py, we'll see we get an integer class printed out. And so this is a way we can test what our data types are. But for now, let's just print all of the types for everything we have here, for all of our variables that we have defined. Oops. Awesome. And now when we run our code, we see we get the integer class for integer1, the float, boolean, and the string class. Another important thing to talk about with variables is we can overwrite them to be something else. So just because we have integer1 here, we can then set it equal to a string. And this is officially overwritten our variable here. So now if we print the type of integer1 and we run our code, we'll see that we get the string class and not the integer class. And if we print integer1 in general, we'll see that we get the value of our variable, which is cool strings. The last thing I want to talk about for variables is the use of keywords. So in Python, there are designated keywords that you cannot store as variables. Some of these are as, so you cannot say as is equal to some value. If, we have with, class, and plenty more. So just be wary if you see some different coloration with your variable names. Say you declared something int is equal to, 34, that might work even though there's the integer function, which we'll talk about later on. But if you did if equals something, that doesn't store into a variable name very well. In fact, it doesn't store into a variable at all. And finally, the reason we use variables is so that we can use them throughout our Python script without having to declare the exact same value over and over again. So, for example, if I just wanted to print 65 over and over again, I could just write print 65. But if I wanted to print a specific value over and over again, knowing that it's never going to change, I would just make my age variable, set it equal to 65, and then print age over and over and over again, and it would never change. So thank you so much for watching, and I'll see you in the next one. Bye. Hey guys, and in this video I want to discuss a couple of concepts that we're going to be seeing in the next couple of lectures before we actually get there. So the first being, when we have variables, like we talked about in the last lecture, right, they're of different data types, or when we go on further, you can understand that they can be whatever we want them to be. So we can define our own types of objects, and then you can make them variables. But generally, variables have functions that belong to them, meaning that the message string, in this case, which this is a string, has the strip function belonging to it. So any strings can call the strip function. Now, there's other functions that we can just import, and for example, this is the int function, and it's built into Python, and we can call that on some variable, and it will try to turn that variable into an integer. And these are things that we'll discuss later on, but I just wanted to let you guys know that functions are essentially things that a block of code that executes, and they will belong to and do something to a variable, or they can be imported, or you don't even have to import them, and you can just call them whenever sometimes. For example, with this int function, you can call it wherever, but other functions you would have to import, and they can then just be used on your specific variable. This might be confusing now, but just try to get through the next couple of lectures, and I think it'll make a lot more sense. I just wanted to introduce you to these concepts before we move forward. Hey, and in this video, we are going to discuss strings in Python. So let's create our file, and we'll call it 2_strings.py. First, we should define a string. So what is a string? Well, a string is an array of characters. What do I mean by a string is an array of characters? Well, each character in a string can be used and accessed individually. And that is a very big difference between other data types in Python, such as integers, floats, or booleans, because we can't just access a specific digit using an accessor. And I'll talk more about accessors and indices in later videos, but for now, just remember that a string is an array of characters. So let's create a string, and we'll say greet is equal to hello. And so now we've created this greet variable with the value of hello. And we'll also create another variable called user name and set this equal to Bob. And so now we've created this username variable with the value of Bob, and both of these are of data type string. So a cool thing we can do with strings is add them together using the plus symbol, which is called concatenation. And what this does is it takes two strings or more and adds them together to create an entirely new string. So we can create a welcome message out of our two strings and say greet plus username, and we can print our welcome message. So when we run our script, and we say Python 2_strings.py. Oh, I forgot the S. Strings.py, we see we get hello Bob. But we actually want to have a space between the hello and Bob. Well, we could put it after hello here, or we could put it before Bob, but we want to keep these variables and their values the same so we can use them elsewhere in our code. So what we should do here instead is add a plus and 2 quotes and a space. Okay? And what this does is it adds the greet string plus a space, so a space string, plus the username string, and saves all of that into the welcome message, which is a string as well. And then we print our welcome message to the console. So now when we run this, we'll see we get hello Bob. Another very useful technique is the format function in Python for strings. So we can define a integer value called age. So we'll set age is equal to 30. And then let's say we want to tell our console or print out to our users that Bob is 30 years old. To do this, we can say print. And instead of just using quotes to print some string, we're going to use the format string. So we just put an F in front of our quotes. And then we can say in brackets, username is, brackets again, age, years old. And so what happens is we're formatting our string, and these brackets allow us to add variables into our string, and it automatically turns those variables into a string if they're not a string already, and then prints it to the screen. So what we can see here is we formatted the username is our age and years old. So this will say Bob is 30 years old when we run our Python code. And we can see we get Bob is 30 years old. Another, so this is essentially doing the same thing as printing username plus, in quotes, space, is plus, oh, sorry. We have to turn it into a string, age plus years old. There we go. And then we run this again. We'll see we get the exact same string, but the latter print statement is a lot more complex than our format string option. And we had to turn our age variable into a string before we were even able to print it. And if we didn't have this, and we took out this string typecasting, and we ran this again, we'll see we get an error that we can only concatenate string with string and not an integer to a string. And that's a very important distinction. So, when you're working with strings and you're trying to print them to your console, it's generally a more accepted practice to use the format string option. Another cool feature of strings is they have a lot of built-in functionality. So we'll create a message, and we'll add a couple spaces in front of it, and we'll say Python is fun, just like that. And we'll add a couple spaces at the end as well. So maybe we want to print our string to the console and have it so it has no white space in front, but we don't want to change the variable itself. So like the message itself. So we're going to print message dot strip, and what this does is it removes white space from the front and end of the string and returns it to us. So when we say Python 2 strings, we see we get Python is fun without any of the spaces in the front or the back. Another very useful function is the lower and uppercase. So we can print message.lower, which turns the entire string into a lowercase string. And we can print message.upper, which turns the entire string into uppercase. So now when we run this again, we'll see we get Python is fun in all lowercase and Python is fun in all uppercase, but we still have the white space on the front and the back of our string because we didn't run the strip function on our message for lower or upper. And now what we can do is print, or we can use another function called replace. And so this will replace some substring in our string with a new string. So to do this, we're going to print message dot replace, and this is the first parameter in this function is going to be the string we want to replace inside of, the substring we want to replace inside of Python is fun. And let's replace fun. And what we can do is replace it with awesome. There we go. And so this finds and replaces a substring in our string variable. And now when we run our code, we'll see Python is awesome instead of Python is fun. And now I just want to make this very clear that when we print message, it is completely unchanged. So we see space, 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 Python is fun, space, space, space. And this is because when we run these functions, they return an entire new string. So say we wanted to change message completely and we wanted to strip out the back white space and the front white space, what we have to do is say message is set equal to message dot strip. And this will return a new string without the white space. And then let's say we wanted message to be all uppercase. What we could do is say message is equal to message dot upper. And then this will return our new string without any of the white space, but all uppercase. And we can print message. And then what we will see is no white space and Python is fun in all uppercase. So this has been a brief introduction into strings. I hope you enjoyed, and I will see you in the next one. Bye. Awesome. So welcome to this next video, and in this one we're going to be talking about basic arithmetic. So to get started, we will create a new file, and we'll call it 3_arithmetic.py. And so this will come in extremely handy. It's how we can, add, multiply, divide, subtract variables from each other, basically like a calculator. So let's define two variables called a, and we'll set it equal to 10, and b equal to 3. So we've defined an integer and another integer. So let's actually see how to add these together. So all we're going to do is print a plus b. And so now instead of having to say printing 10 plus 3, we can just print a plus b. But we can also do the same thing and just say print 10 plus 3, and we would get the same output. So let's go ahead and run our new Python script, and we'll say 3_arithmetic.py. Enter, and we get two 13s, which is what we wanted. So let's go ahead and let's actually delete this one. And so let's say we wanted to add one variable to another and then save that into an entirely new variable. How can we do that? So to do that, we will say c is equal to a plus b. And what happens is, we get a plus b, and it gets saved into our new variable c. And so now we can just print c, and we will get our two 13s again. So now let's talk about subtraction. So we can do print a minus b, and we should get 7. So all we have to do is run this again, and we will see 13, 13, 7, which is exactly what we expected from subtraction. And then again, to save that into a new variable, we can just say c is equal to a minus b, and we can print c again. And you'll see something interesting. So in our script, because Python executes top down, we have a is equal to 10, b is equal to 3, we get to 13, but then we set c equal to a plus b, and then we print c, which is going to output 13, but then we set c equal to a minus b, which is 7, and so we will see c as 7 here. And I just think that's important to mention because we reassign c to a new value, and when we print that out again, we get it here, but when we print it here, it still is at 13, so it doesn't print out 7. So if we were to print this again, or if we run this again, we see we get our two 13s, and then we get our two 7s, which is exactly what we expected. So next we can talk about multiplication. So in order to multiply, we just do a times b, and then we can say c is equal to a times b, and we can print our c again. And when we run this, we should get 30. Yep, there we go. So we get our two 30s. And then for division, we will just do a divided by b, and then c is equal to a divided by b, and we can print c. And run this again. And so something interesting happened here. Now c, instead of being an integer value, it's actually a float. And so why did that happen? Well, that's because, 10 divided by 3 doesn't equal a whole number. So Python decided that it should turn the return value into a float value instead. Now, how do we actually get a integer value from this? So instead of one division, so we can comment this here, and we can say normal division, which can return a float. If it's a whole value, it won't, but it can return a float. So let's say we only want to work with integer values. Well, we can print a divided by with 2 division, and this is what we call floor division. So with floor division, it will always go down to the nearest integer. So if we have 3.3 repeating, right, it's going to round down. So it doesn't matter if you're at like 3.9, it'll always be 3. So if we go ahead and we print, and we say c is equal to a divided by b, so floor division, and then we print c, we should always get 3. There we go. And we can even say, actually, no, I think that's good. So this is floor division, and that way we always get an integer back. But it always rounds down. No, even if you're at 3.9 repeating, it'll always go to 3. So the next thing we want to talk about is how to do exponents in Python. So to do exponents, we just do 2 multiplication symbols. So a to the 3rd power, or I'm sorry, a to the b power, which is 10 to the 3rd power. And we can say c is equal to a to the b power, and we can print our c value, and then we can run it, and we can see that we get 1,000. So it's 10 times 10 times 10, and 10 times 10 is 100, and then 100 times 10 is 1,000. So we get the correct values. So now let's say we want to do a lot of different, and actually let me comment this out for you guys. So this is exponents. This is equal to 10 to the 3rd power. There we go. But now I think we should talk about precedence. So Python does follow PEMDAS rules. So if we print out 2 plus 3, and then we say times 4, what happens is it's 4 times 3 first, and then we add 2. So it's not 2 plus 3 times 4. We'll get 12 plus 2, so we should get 14. And so if we go ahead and we run this, we'll see, okay, we get 14. So just remember that. And if you want to control what happens at all times, what you can actually do is just use your parentheses. So we can print 2 plus 3 times 4, and we will get 20 instead. There we go, we get 20 because we do our addition first in these parentheses, which is 5, and then we multiply that by 4, which gives us 20. Awesome. And so that is, and so let's comment here, and we will say controlling the order. There we go. And so, yeah, that's how you can control your order, and this is basic arithmetic in Python. Thank you for watching. Hey guys, and in this video, we're going to be talking about input and how we can use input from the user to drive our Python script. So, without further ado, let's create a file, and we're going to call it for_and_input.py. So, how do we get input from a user in Python? Well, actually, it's very, very simple, and all we need to do is type in input, and it's a function, so we call it the input function, and we give it some string value. So we're going to say enter your age with a colon. And essentially what's going to happen is this will print in our terminal, and we can type over here and get some value. So we're just going to run this really fast. Oops, sorry. So Python for_input.py. And we can see it asks us to enter our age, and I can say 65, and it just ends our script. So how can we actually get the value that is given to us by the user and then use it in our Python script? Well, that is also very easy. To do that, we will just say user_age is equal to input. And so what happens is when we get prompted in our terminal to enter our age, or a console, those are synonyms, we will save the 65 into the user age variable. But it's also very interesting because if we say, if we print the type of user age, you'll see something interesting. So let's run this really fast, and I'm going to say 65, and I press enter. And if we see here, the type is string. So why is that? So we can't do our normal arithmetic on this because it is of type string. Well, it's because in the terminal, you're typing in text, and so the Python code for input automatically takes whatever you give it and it turns it into text for the variable. So we actually want to change this, the type of user age, so that we can use it with our normal arithmetic, how we would with an integer value. So to do that, we can just leave this here. But what we're going to say is user_age is equal to int, and then in parentheses, user_age. So int is a built-in Python function that will take in a string value, and then it will turn it into the integer data type. So if we run, we can print type user age, and we should get it as an integer now. So we will run this, and we'll say 65, and we'll press enter, and we can see we get string, and then we also get int as the second one. So we have officially turned user age into an integer value, which we can then use for arithmetic and other things. Let me actually get rid of that. Cool. The next thing we want to do is maybe we want to print to the screen that we have received our user's age. So instead of now printing the type, let's use our format string function that we know how to use with the f, and we can print the user's age is, and maybe we can put a colon, and we can put our curly braces user age. There we go. And so now we can run this, and we'll say 65. We'll press enter, and then we get the user's age is 65. So I actually want to point something out to you guys really, really fast also. Let's say that when we run this, we add 5 spaces, or like 3 spaces in front, 65, and then a couple spaces at the end. When we press enter, it doesn't matter. It still functions properly. That's because even though we're passing in essentially this into this integer function, it will call the strip first. So it'll get rid of the white space, and it will just leave our integer value here, and then it will turn it into an integer value. So you don't have to worry about white space for this, but if you wanted to, you could do it, and you could just say user age before we turned it into an integer value is equal to user age dot strip, and that would take away the white space regardless, but it doesn't matter. You can just say, 65 space, and then we get the same output. We don't get any errors. Now, if somebody does put in like the instead of an integer, what we will get is a error because it doesn't, the integer function doesn't understand how to take the and turn it into an integer value. So we'll talk about errors later on in the course, but do be warned that if you type in a regular string or just some text and we try to convert it into an integer, you will get an error. So let's go ahead and delete this because it's pointless, and we'll save the file. So cool, now we actually printed the user's age, but let's actually get the user's height, but let's get it this time in meters. So we're going to say user height is equal to input and enter your height in meters. Okay. And so then for meters, we're likely to get a decimal point. So we're going to say user height is equal to float user height. And so we're going to convert our decimal into a float value from a string. We're going to convert the user's input into a float value and save that into the user height variable again, overwriting the original one. And then we can print format the user's height in meters is colon, and in our curly brackets, user height. There we go. And let's go ahead and run our function. And we'll say we're 65 years old and 1.75 meters tall. And you can see we get the user's height in meters is 1.75. So we've successfully turned our string into a float. The next thing we want to talk about is how can we take in multiple values at the same time. So this is quite convenient. So let's say we want to take in a couple numbers, like maybe it's a coordinate. So we want to get XY coordinate. So we will just say coordinates is equal to input and enter XY coordinates. There we go. But let's define how we separate them, which is X and Y coordinates separated by spaces. There we go. And so we told the user that we are expecting the X and Y coordinates separated by spaces. And so that's exactly how we need to get our coordinates. So what we're going to say is X comma Y is equal to map and int values dot split. There we go. Oh, I'm sorry, coordinates dot split. So don't worry, I will go through exactly what's happening here. Basically what's happening is coordinates is going to be a string, and so we're splitting the coordinates up by spaces. That's what the split function does here. So just for an example of what's going to happen, let's say we have the input from the user is equal to 12, 13. Okay. When we call the split function, it's going to create basically an array, which we'll get more into later, and it's going to be 12, 13. And then what happens is it calls the map calls the integer function, so we're passing in the integer function, which we actually call right here, and it will call that over everything in the array. So then we will get an array of 12, 13, and then what happens is it deconstructs this array into this XY variable. So it'll say 12 into X and 13 into Y. So just understand that that's what's happening. You don't have to memorize this process, but if you want to take in multiple coordinates, you can just say, okay, I'm going to call the map and I'm going to split it in, split the string by spaces, and then we'll call the integer function, and so that'll return our XY coordinates. And so now we can print X comma Y, and we can run our function, And we're going to say our age is 65. Our meters is 1.75. And then it's going to ask us to enter our XY coordinates. So we'll say 12 and 13 split by spaces. And so now we have 12 and 13. So maybe we don't want to split by spaces. Maybe that's weird. You know, we expect an X and a Y to be separated by commas. So actually what we want is new coordinates. We're going to say is equal to the input. And we're going to say enter X, Y coordinates split by commas. There we go. And then we're going to say X comma Y is equal to map int, and we're going to say coordinates dot split again. But this time what we're going to do is actually give it a string of comma. And so what's going to happen here is instead of splitting by spaces, which is the default for split, when it gets a string, so we'll say the input was that the user gives us is 12 comma 13, what happens is input, it will split it and turn it into 12, 13, just like this, into an array. And then it runs the integer over it, and then it deconstructs the array into our values. So now instead of splitting by spaces, we now split by commas, and we can print our x, y, and we will get, 65, 1.75, 12, 13, and 12 comma 13, and oops, I got an error. Because I forgot to say new coordinates here. There we go. So let's go ahead and run this again, and we'll get 65, 1.75, 12, 13, and say 12, 13. And now we get our 12, 13 here because we are splitting it by the commas now. And so, yeah, that is how to do user input and how to convert our user input into our specific data types that we want. You could leave it as a string, or you could turn it into, your integers or your floats. Awesome. Thanks for watching. Bye, guys.